All right, we're going to finish up this worksheet here. We're going to solve the last three problems, 18, 19, and 20. These are actually super straightforward, but before we do, let me just review real quick. So uh, problems 1 through 10, what we did is we used the traditional future value problems, right? We used these particular formulas to calculate future value, present value rates, and the number of time periods. Now, this assumed that these were lump sum payments, either lump sum future values that we wanted to calculate. We wanted to calculate, say, um, the value of some retirement account in the future, or we wanted to take the present value. So we treated these things as lump sum. Now what we're doing here is we have a present value of an annuity, right? We've been using that payment function here. And so the math becomes a little more complicated. It's way easier in Excel and on the financial calculator to do this. Also, we can calculate the future value of an annuity payment or an annuity investment. So we're gonna use this particular formula. Actually, we're going to use Excel and allow Excel to use this particular formula to calculate the future value of, say, a constant investment into a particular retirement account over your lifetime, your work lifetime. Okay, so let's do this. So in 18, how many months will you have to invest $500 in order to have $4 million in your retirement account if you can earn an interest rate of 12%? Now assume you don't have any money in the retirement account currently. All right. So again, the three questions we ask is, what do we solve for? How frequently does interest compound? And what are my outflows and what are my inflows? All right. So what are we solving for? It looks like we're solving for the number of months that it will take. So we're solving for the number of periods. My outflows are going to be this $500 investment each month that's coming out of my pocket. Therefore, that's going to be the negative, the outflow here. And then I'm going to have a $4 million inflow uh, into my retirement account. Okay, so that's going to be my inflow. So let's solve this real quick. I'm going to take $500 negative, and I'm going to put that in the payment function because that payment is going to be made from now until I retire. I can use this payment function. My future value is going to be 4 million. Okay. I don't have any money in the retirement account, so that's going to be zero. Now my interest rate is going to be 12% per year. To get that into a monthly rate, I'm going to take 12 divided by 12, which is equal to 1% per month. And I compute the number of time periods, which is going to give me the number of months that I have to invest $500 in to reach my savings goal. That's 441 months. If I divide that number by 12, I get 36.8 years. Okay. So pretty straightforward. Number 19, suppose you're 28 years old, you're looking to start a retirement account. You desire to have $6 million in your account when you retire at age 65. You feel you can afford a monthly investment of $700. What is the rate of return that you're going to need to meet your savings goal? So what are we solving for? We're going to solve for rate. My outflows are going to be the monthly investment of $700. The inflow is going to be the $6 million when I retire. Okay, so I'm going to say equals rate. All right, the number of periods are, I'm 28 years old and I'm going to retire when I'm 65. So to figure out what this is, I'm going to take 65 minus 28. I've got 37 years to retirement, but how frequently will interest compound? Again, the rule of thumb is interest will compound as frequently as you make your payments. So these are monthly investments. So I'm going to multiply that by 12 to get the number of months. Okay. So I have 444 months of investing $700. That $700 is an outflow, so it's going to be negative. I don't have any money in my retirement account right now, so present value is zero, and future value is going to be 6 million. Compounding at the end of the period. All right. And that gives me an interest rate of something close to 1%. Let me get you some decimals there. And that 1% per year or per month? Since we've transformed everything into months, what we got to do is we got to multiply that thing by 12 to get what we need per year. So we need an interest rate of about 12.157% per year in order to reach our savings goal. Again, pretty straightforward problem there. And now hopefully you're seeing the benefits of being able to use this payment function. Let's solve this last one. Suppose you're looking to begin investing $500 a month into an account that pays 13.5% per year. You're currently 25 years old and you plan to retire in 40 years when you're 65. What will this account be worth upon your retirement? Again, what are we solving for? Got to solve for the future value. How frequently will interest compound? It's going to compound monthly. And my outflows are going to be the monthly investment. My inflows are going to be this future value of the retirement account. I'll do that on the financial calculator here. So $500 negative outflow under payment. Present value is 0. I'm solving for future value. My interest rate is going to be 13.5%. Divide that by 12. And I get 1.125% per month. I enter that into I over Y. And I'm going to retire when I'm 40 years old. I'm not going to type in 40 here and put it in the number of time periods. I got to multiply that by 12 because I'm going to make this payment 480 times. Compute future value. If I invest $500 into an account that pays 13.5% per year over a 40-year time period, I'm going to have $9.5 million upon retirement. Okay. Hopefully this was useful. That does the trick for all of the problems on this worksheet. We'll make some more videos going forward.